Hi everyone, Mr. Oliver here from the James Prendergast Library, here with another Makerspace Steam video for you guys. So today what we're going to be talking about is electricity. And to do that, I'm going to show you guys a circuit using our snap circuits that if you guys have ever come into our Makerspace, they're a lot of fun. You get to do a lot of cool different projects with them. Today, so we're going to be talking about what's called basic electric circuitry. It's important for students to learn the concept of energy, where energy comes from, and how it's used. And we're really focusing on the fourth grade concept of the movement of energy from one source to another object. Now there's several different kinds of energy that we use in general throughout our daily life. Today we're going to be talking about battery powered, but some houses may have something like this. And this is a solar panel, and so the energy would come from the sun. Other places might have wind powered. If you ever drive down the highway, you might see some of the large windmills, wind turbines. And depending on where you live, you also might have nuclear powered energy. But today, we're talking about battery powered. And so let's look at this again, because we always got to bring in the next generation science standards. And this one we're talking about is that students need to make observations to provide evidence that energy can be transferred from place to place by sound, light, heat, or electrical currents. And so let's talk about light first. And so I have this circuit here that we have the battery down here. The battery power is going to go through here. I will turn it on. It'll go through the light, it'll power the light, and then come back here. And I'm actually, before I show you the actual working circuit, I'm going to take this off. And I'm going to turn it on. And as you can see, the light doesn't come on. And that's because when you have a circuit, it needs to make a loop, which is kind of what a circuit means. So if you think about when they talk about circuit training, you have to run around and you make a complete circle. So I'm going to turn this off because anytime you're messing with power, electricity, even little amounts of electricity, you always want to make sure you turn it off before you do anything with it. Turn that off, or connect that, and now I'm going to turn it on. And as you can see, we've made a complete circuit. It's turned on, and power is flowing through here and making light. I'm going to turn this off, and I'm actually going to reconfigure my circuit real quick. And what I'm going to do is I'm going to add this fan blade, and I'm going to disconnect the light from it. So now I have a second circuit. The light's up here, it's not connected, and I'm going to put this on here and then turn it back on. And as you can see, this circuit now is powering the motor and making the fan move. And you can actually see that it has a little bit of force that can make this paper move. Actually, it feels really nice. It's a little warm in here today. So I'm going to turn that off. And what I'm going to do next. So we found out that these two batteries here will power this light, and it will power this fan. Now the question is, can this battery power this light and this fan at the same time? So let's try it. So what I'm going to do, make sure it's turned off. I'm going to connect the light to the off switch, and then I'm going to connect the light to the fan. Put the fan blades back on. And we're going to turn it on. And as you can see, the light's dimmer, and the fan's not moving as fast. Remember, I had that really loud whirring sound when it's going. So this is really important when we start talking about power loads in houses and cities. When you have too many things connected at once to the same power source, not everything is powered fully. there's a certain amount of power load, power drain that happens. And that's with the transfer of energy. There's only so much energy to move around that nothing is getting its full source. There are different components you could add to circuits and to power systems to make them function better. Because otherwise, we'd have to be building a power plant every single block, or multiple power plants for one city one city at the size of Jamestown. It's just not really efficient. It's not really good for the environment. And so there's different components. And so over here we have the resistors. And what these do is that if too much energy is put into the system, these resistors protect what they're connected to. So you think if like a lightning bolt has a lot of energy in it, and if a lightning bolt hits something very important, you don't want it to explode, which can happen. If you've ever seen a transformer get hit by a lightning bolt, it's very scary, very dangerous. But these resistors help prevent some of those big scary accidents from happening. Over here, I'm going to try and pull this one out because we only have the one. Now this is an amplifier, and what this does is it amplifies the amount of energy that comes into it and then goes out. So it takes a little bit of energy in and then has a lot of energy coming out. And so that's how you can power big things with just a little bit. And then this, okay, so this right here is called a capacitor. And what capacitors do is they store energy and then they release it in big bursts later on. And this is important. It also helps prevent some stuff from getting shocked. And they also store energy for future use. So energy will come in, especially like with solar panels. So solar panels are great. They're powered by the sun. But we don't have sun at night, and the moon and other light sources aren't always powerful enough to power the solar panels. So if you live in a situation where you only have solar panels, you want to have some of these so they store the energy and release them when you have to get up in the middle of the night to use the bathroom, or if you need to turn on a light for somebody. And that is actually all the components that we have here. There is one other thing that I mentioned that's called the transformer, and it's not the giant robots that turn into cars. For you older kids, you may have learned in science about two different types of electricity. One's called AC, one's called DC. AC stands for alternating current, and what happens is the current moves in a circle. It goes from one object to another and then comes back. And it does that continuously throughout, and it keeps the power. And it allows us to power objects very far away from the power plant. Now with DC, it's direct current. So what you need to have is a power plant is directly connected to the object, and it's kind of a one-way street. But we don't have any of those in here because it's usually for much bigger loads of energy. So, all right, guys, I hope this was interesting, and I hope that sometime soon we can see you guys all in our makerspace. Have a good day.